Imagine a universe teeming with life, civilizations far beyond our own, and intelligent beings reaching out to us. It's a tantalizing thought, isn't it? This idea has captured the human imagination for centuries. From ancient myths and legends to modern science fiction, the concept of intelligent life beyond Earth has been a recurring theme, stirring our curiosity and wonder. Yet this is no mere flight of fancy. Scientists across the globe are actively seeking answers to this profound question. Will we ever make contact with intelligent alien life? The quest is filled with possibilities and challenges, a journey of discovery that stretches our understanding of the universe and our place within it. As we stand on the precipice of discovery, let's delve into the scientific pursuit of this monumental question. The search for extraterrestrial intelligence, or SETI, has been tirelessly scanning the cosmos for decades. This ambitious endeavor began back in the 1960s, sparked by a simple yet profound question: are we alone in the universe? Ever since then, arrays of giant radio and optical telescopes have been pointed towards the stars, patiently listening and watching for signs of intelligent life beyond our world. SETI's mission is not a simple one. The universe is vast, almost unimaginably so. There are billions upon billions of galaxies, each containing countless stars and planets. The task of sifting through this cosmic haystack in search of a needle, that is, signs of extraterrestrial intelligence, is a daunting one. Yet, SETI scientists are undeterred. With every passing day, they collect and analyze enormous amounts of data, hoping to detect a signal that does not originate from natural cosmic phenomena, but from an intelligent civilization. The primary tool in SETI's arsenal is the radio telescope. These instruments, such as the Green Bank Telescope in West Virginia or the now collapsed Arecibo Observatory in Puerto Rico, scan the sky for radio waves. Why radio waves, you may ask? Well, radio waves can travel vast distances without being absorbed or scattered by interstellar gas and dust, making them a logical choice for any civilization trying to make its presence known across the cosmos. Yet the search is not limited to radio waves. SETI also employs optical telescopes in the hunt for laser signals, another potential means of interstellar communication. The idea is that advanced civilizations might use powerful lasers as a way to signal across the vast distances of space, much like a cosmic lighthouse. The vastness of the universe presents a daunting challenge, but our search for cosmic neighbors continues. With every star we examine, every signal we scrutinize, we come one step closer to answering that fundamental question: are we alone? No matter how long it takes, our curiosity, our thirst for knowledge, compels us to keep searching, to keep listening, for that one signal that might forever change our understanding of our place in the cosmos. So, what are the odds of making contact? The Drake equation gives us a theoretical estimate. Enter the Drake equation, a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. It's named after Frank Drake, not for reasons of vanity, but because he initiated the first scientific meeting on the search for extraterrestrial intelligence, SETI, and formulated this equation as the agenda. The Drake equation includes several variables, each representing a factor essential for intelligent life. These include the rate of star formation, the fraction of those stars that have planetary systems, the number of planets that could potentially support life, the fraction on which life actually appears, the fraction of life that evolves into intelligent beings, the fraction that develop technology that releases detectable signs into space, and lastly, the length of time such civilizations release these signals. Each of these factors is complex, and our understanding of them is evolving as our knowledge of the universe expands. For instance, with the discovery of exoplanets, we can make better estimates about the fraction of stars with planetary systems. Similarly, our understanding of life's resilience helps us better estimate the planets that could potentially support life. However, as we go further into the equation, our estimates become more speculative. We know life evolved into intelligent beings on Earth, but how likely is this on other planets? Even more uncertain is the fraction of civilizations that develop detectable technology and the length of time they release these signals. So while the Drake equation does not give us a precise number of civilizations out there, It provides a framework for understanding the factors involved and allows us to make educated guesses. The values we put into the equation reflect our scientific understanding, as well as our assumptions and prejudices about life, intelligence, and technology. While the Drake equation provides a framework, the truth remains elusive and the search goes on. Our search for alien life begins at home, in our own galaxy, with the discovery of exoplanets. These celestial bodies, orbiting stars beyond our sun, have become the focus of astrobiologists in their quest to find worlds that might harbor life. The key to this search is the concept of the Goldilocks zone. Much like the porridge in the classic fairy tale, a planet needs to be neither too hot nor too cold, but just right for life to exist. This zone, also known as the habitable zone, is the perfect distance from a star where a planet could potentially maintain liquid water, a vital ingredient for life as we know it. In the past couple of decades, thanks to advances in technology, the number of confirmed exoplanets has skyrocketed into the thousands. Among these, a significant number have been found in their star's Goldilocks zone. These planets, aptly named Goldilocks planets, are the prime focus in our search for extraterrestrial life. One such discovery that ignited a spark of excitement in the scientific community was the exoplanet system TRAPPIST-1. Located a mere 40 light-years away, this system boasts 7 Earth-sized planets, 3 of which lie within the habitable zone. These discoveries are not just thrilling for their potential to host life, but also for what they can teach us about planetary formation and conditions throughout the universe. Each new exoplanet found provides more data to fuel our understanding and refine our search criteria. Yet it's important to remember that being in the Goldilocks zone doesn't guarantee life. There are other crucial factors to consider, like the planet's atmosphere, its geological activity, and whether it has a magnetic field to shield it from harmful solar radiation. Nonetheless, the discovery of these Goldilocks planets continues to fan the flames of our curiosity and hope. As we gaze upon these distant worlds, we can't help but wonder if somewhere out there, someone or something is gazing back. Every new discovery brings us one step closer to answering the question, are we alone? But if the universe is teeming with life, why haven't we heard from anyone? This is the Fermi paradox. Named after physicist Enrico Fermi, the paradox grapples with the contradiction between the high probability of extraterrestrial life and the stark lack of evidence or contact with such civilizations. The Milky Way alone contains hundreds of billions of stars, many of which likely host planetary systems. If even a small fraction of these planets harbor life, and if only a small fraction of that life evolved into intelligent beings, the galaxy should be teeming with civilizations. Yet we've encountered a profound silence. This paradox has puzzled scientists for decades, prompting a slew of theories. Some suggest that intelligent life self-destructs, others propose that civilizations are avoiding us, or perhaps we're just not listening in the right way. The silence of the cosmos is deafening, but there are many potential explanations for our cosmic solitude. If we can't hear them, maybe we can see them. That's the idea behind looking for technological signatures. Technological signatures, or technosignatures, are signs of technology that might indicate the existence of advanced civilizations out there in the cosmos. Think of them as cosmic breadcrumbs, clues left behind by technologically advanced species. These technosignatures could take many forms. They could be megastructures like a Dyson sphere, a hypothetical structure that an advanced civilization might build around a star to capture all of its energy. They might be traces of pollution in an exoplanet's atmosphere, indicating industrial activity. Or they could be powerful artificial signals, similar to our own radio or television broadcasts, but from light years away. However, spotting these technosignatures is no easy task. It's like trying to find a needle in the cosmic haystack. Our current technology is just starting to reach the necessary sensitivity to detect these potential signs. And even if we did spot something unusual, it would take careful analysis to determine whether it's truly a sign of an extraterrestrial civilization or just a natural phenomenon. Now, let's flip the coin and talk about messaging extraterrestrial intelligence, or METI. While SETI listens for signals, METI takes a more proactive approach. sending messages out into the cosmos in hopes that someone or something might hear us. But this isn't without controversy. Some scientists and philosophers worry about the potential risks of revealing our presence to unknown entities. Yet proponents of METI argue that the potential benefits outweigh the risks. After all, making contact with an advanced civilization could lead to unprecedented scientific and philosophical insights. It could answer one of humanity's oldest questions: are we alone in the universe? Whether we detect a signal or send one, making contact will have profound implications. It's a thrilling, yet daunting prospect. But as we continue to explore the cosmos, we inch ever closer to potentially answering that monumental question. Who knows what the future of our cosmic quest might hold? As our technology advances, so does our ability to explore the cosmos. The future of our search for extraterrestrial intelligence is bound to be driven by two key factors: advancements in space exploration technologies and the increasing role of artificial intelligence in data analysis. In the realm of space exploration, we're on the cusp of some truly exciting developments. For example, the James Webb Space Telescope, set to launch soon, promises to peer deeper into the universe than ever before. It will be able to detect atmospheric biomarkers, compounds that could indicate the presence of life on distant exoplanets. In addition, new propulsion technologies could potentially allow us to send probes to neighboring star systems within a human lifetime. Breakthrough Starshot, a project aimed at developing light sail technology, is one such promising endeavor. If successful, it could send a fleet of nanocrafts to Alpha Centauri, our nearest star system, in just over 20 years. But space is vast, and even our most powerful telescopes can only see so much. That's where artificial intelligence comes in. AI algorithms are being developed to sift through the colossal amounts of data we receive from our telescopes, looking for patterns and anomalies that could indicate the existence of an advanced civilization. Machine learning, a subset of AI, is particularly promising. These systems can be trained to recognize the signals we're interested in and then scan our astronomical data to find them. In fact, machine learning has already been used to discover new exoplanets in the data from the Kepler Space Telescope. The use of AI in our search for extraterrestrial intelligence isn't just about finding a needle in a haystack, it's about finding a needle in 1,000 haystacks. But as our algorithms become more sophisticated, our chances of finding that needle increase. The question remains, will we ever make contact with intelligent alien life? Only time will tell. The search for extraterrestrial intelligence is more than a scientific endeavor. It's a journey of self-discovery. As we delve deeper into the cosmic abyss, we're not just seeking alien life, we're exploring the profound question of our existence. How do we fit into this expansive cosmic tapestry? Are we alone, or is the universe teeming with life? This quest doesn't just push the boundaries of our scientific understanding, but also our philosophical consciousness. It forces us to grapple with the magnitude of our universe and our place within it, urging us to maintain a cosmic perspective. Whether or not we make contact, the search itself is transformative, broadening our horizons and challenging our perceptions of life and existence. As we gaze into the cosmos, we realize that we are not only searching for alien life, but also for a deeper understanding of our place in the universe.